Hello everyone. In this lesson, we will learn how to change the position of an object in space using a script. I will tell you how to read user actions. We will continue studying programming, and we will study the if operator. Nothing interesting can be done without it. Why are we programming in Unity? What is the purpose of the scripts we're writing? It is a change of the scene state. For example, when we move an object, we want to take a transform component and change its position. Or we change the color of an object, some camera parameters, light sources, and other stuff. In order to be able to change these parameters, we need to know how to call them. All the parameters of all components. This will open up a very wide scope to do something interesting. So, in this video, we'll talk about how to change the parameters of different components and objects. We've talked about the fact that all objects in Unity are called game objects. Let's see what we can do with this game object. Here I have a box, there is a script on it now. Now it's empty. I deleted everything from it. Say, for example, we have a game object, this property. Game object is the object on which there is a script. That means we are now calling this box. Then we put a dot here, and look at what methods this object has, what we can do with it. For one thing, it has a name. Let's show this name in the console now. We write debug.log and then write the name of the object in brackets. Game object name. A semicolon. You can output something else about this object in addition to the name it still has. You can put a dot here and we fall into this object and see what it can do. For example, it also has a tag. Let's save this and see what is shown in the console in Unity. We won't use it in the near future, but the tag is just a way to create some object categories, to bring different objects under one tag so that they behave in a certain way. So, there you go. Its name is cube, and its tag is untagged. That's actually how it is written here. It's boring to show it. Let's change something. For example, the name can be changed. Let's write GameObjectName equals and in quotation marks, because the name is a certain line. Let's name it MySuperCube. We can also call object methods and, for example, what we often had to do with game objects is enable and disable them. For example, a menu is hidden at the beginning and appears when something happens in the scene. There is a setActive method for doing this, and you need to write true or false in brackets. True it will enable, false it will be disabled. Let's save it and see what happens. You need to click play every time to make our start method work. That's great. The cube has been renamed, and now its name is MySuperCube. Although it is the most important object for us, but we can't do anything particularly interesting with the game object yet. Let's move an object. For this, we have the transform property. By the way, I've just commented out these lines so that they are temporarily not active. This is done by putting these two slashes here. We've seen them before. Commenting out is used for two tasks, to explain what any part of your code does. For example, it is written here that the start is called before the first frame. And for tests, if you just want to temporarily hide something, but don't want to delete it. The transform means that we are calling the transform component of the object on which this script is. Let's see what it has. For example, the position of this object. Let's assign it. We write transform position equals new vector 3, and then we need to list the coordinates in brackets, separated by commas. Like this 0, 2, 0. It will move to the center of the coordinates, and 2 meters up, and then a semicolon. Just remember that this is how it is written. We want to assign a position. A position is not just a number, it is a vector. The idea is that we need to create a new vector object and the actual position will be equal to it. For now, you can just remember that the syntax looks like this. Then you can also set the turn of the object. This is called Euler angles. This parameter is also set by a vector. We also write new vector 3, and then in brackets. Let's make it turn like this, 0, 45 and 30. We can also change the scale of the object. This property is called transform local scale. Let's say 1, 2, 4. Don't make the scale 0, or it will just flatten and disappear completely. Let's save this and check Unity. That's it, our box took this position, and it turned and was scaled according to our specifications. We have already influenced our scene. These are the properties we normally see in the inspector. They will be called just as in the code. We are writing, but in the case of the turn and scale, the situation is a little bit different. This property is called turn. Unity called it that just for the sake of brevity, but it's really called Euler angles. This is a way of specifying the turn through angles, in degrees. Rather than just scale, the scale is called local scale. You just need to remember it, write it down somewhere. Just setting coordinates at the start is pretty boring, so let's make something change in the process, and we'll write it in the update. I'll transfer this line to the update, and then I'll comment everything out here. Nothing will change now, but each frame will be assigned the same position. We can write this, transform position equals transform position plus a vector. That is, we sort of tell it that its position should be equal to its current position, plus a small value. Let's add something small here. 0.01f. I'll explain what f means, but for now, we'll just write it and let's see what happens. That's it, we've started the game. As we wrote, the box moves up. Every frame it moves by this amount, by this offset. Now, let me explain the letter f. If you don't write it, then it is emphasized here as an error. The thing is that there are different types of decimal numbers in C#. That is, if a number has a dot, then it can be of different types. There is a float type, or, for example, a double type. We must explicitly indicate this with this letter. Different types of decimal numbers are needed to achieve different accuracy. These types take up different memory space. For example, a float type needs 32 bits. In Unity, as a rule, we work with floats. They take up less memory, but the number is accurate to set a position, for example. In other words, you do not need to set the position with an accuracy of nanometers. If you don't go into details, then the rule is as follows. If you write a number with a dot, then always add the letter f to it. Great, we've already done something moving using the script. Another thing we need in games is to read what the user enters. The user presses a button, and it is some kind of game interaction. So we'll do it this way. If input get key W, then something must be done. So, here we use the if operator. Let me quickly explain how it works. It has round brackets at the beginning, and in these brackets a certain condition is written that must be fulfilled. In this case, we wrote if input get key code W. This is how we read the pressing of the W button on the keyboard. You can certainly write any other button here, a space, for example, but I think it will be easy to understand how to use this. And then there are curly brackets. In them, we write what should happen if this condition is fulfilled. For example, I want to move an object only when the W button is pressed, so I will move this line here, and let it move more by 0.3. If we press the S button, it's a down button, it will move down. You can copy it. Keycode S. You can, for example, subtract this vector. That's it, minus. Save it. Great, I press W and it moves up, S and it moves down. We have already created some small control. This control will work if you have now switched to the game window. If we are here and press the buttons, it does not work, don't be surprised by that. In fact, a blue stripe above the windows is shown here, because if a window is active at any given time, the game window should be active. Let's also rewrite these long lines. Transform position. I think it's clear what it means, but you can write it more briefly. There is this operator, plus equals. This is the same thing as was written earlier, but shorter. It's like changing the current value. This minus looks strange now. For example, you can write that we move by the value of such a vector minus 0.03. What else can be read, other than pressing buttons on the keyboard? There are buttons on the mouse. Let's learn how to work with them. Here you also write if, then input. Input is a class that contains everything about user input. Another way is the getMouseButtonDown method. When does it trigger? At the moment of clicking the mouse. Then there's buttonUp, this is the moment of releasing the mouse button. Accordingly, we choose down, and here we need to write a number in brackets. 0 means the left mouse button, 1 means the right mouse button, and 2 means the middle mouse button. Let's say I want to use the left mouse button. This is the condition, and then we write in quotation marks what should happen. For example, the object scale should change. Let's say we multiply transform local scale by a value. Here you can write multiply equals 1.2. We will increase it by 20% thereby. Click the left mouse button and reduce it by 20%. Multiply equals 0.8. We can see it still moves with buttons. The right mouse button increases it, while the left mouse button decreases it. What else should we know about user input, other than the buttons that are pressed? How about the way the user moves the mouse on the screen, the coordinate of the mouse on the screen in pixels? It would be nice to find out, then we can move it left and right and turn something. We will need to turn the character in the game, for example. To do this, we have an input method, more precisely, the input mouse position property. This is the position of the mouse on the screen in pixels. We can also find out in more detail where it is on the screen along the X or Y axis. There's also Z, but it's a pretty useless property. The mouse moves on a plane, so we are interested in X and Y. There's no point in writing it for no reason. It's like a mistake. Something needs to be done with this property. For example, let's equate the object turn to the position of the mouse on the screen. Something like that. Transform local angles equals vector 3, as we have already assigned a turn to an object once, and now it will be 0 along two axes, but the value of the turn along the y-axis will be equal to the coordinate of the mouse on the screen. Save it. No conditions are needed here, it's just beyond ifs. Now I move the mouse, and here we see how its turn changes when moving left and right. So, we have reviewed some methods regarding user input. There's also get key. This method triggers in every frame while the W button is pressed. I am holding it down, and until I release it, the box keeps moving and moving up. But there is also a get key down method. It is better to write it like that again. Get key down. It triggers when you press the button for the first time. A get key up when you release the button. You can experiment with it on your own. In this lesson, we wrote a lot of different commands. If you don't fully understand how to work with the code now, that's okay. You just need to practice more to develop this skill.